We have here, that's example 4. Let's make this A again. We have here the 10th root of y to the 5th. How would you write this rational exponent as, well, my directions are a little bit backwards here, but that's okay. How to write this rational exponent, this radical as a rational exponent. And I'll clarify it in your notes, but I want to talk about this one. How would you write this radical as a rational exponent? Let's go back to that.
Y 5 on 10.
Our base happens to be a y. Our index is a 10. Our exponent is a 5. So that would be 5 over 10. And remember to reduce. Okay. So then what I want you to do is to write this answer as a radical now. Remember, your index is the denominator. Your exponent will be what's in the numerator. It's to the first power. There's no need to write 1 there. Okay? Let's do another one. Let's say the 4th root of r squared s to the 6th. Now, how would we write this out as a rational exponent? What is our base?
R squared S.
R squared s to the 6th, all raised to the 1/4. Okay. So I'm not sure if you have one like this in there in math, my math lab, but I want to do it. Okay. All right. So let's simplify. So if you, all we did was just convert this radical to a rational exponent. That was it. Nothing else. Now it's asking us to simplify it. Now we're going to go back to what we know about rational exponents. What happens whenever you have a series, or you have some factors raised to a power? Remember, the rule says that we want to take that outer exponent and we're going to distribute that to each factor. So as we distribute this this 1/4 to r squared, I want you to see what happens. You've done this before. What makes it confusing is that it happens to be an exponent that happens to be a fraction, but you've done this. Because if I took away that 1 and over, and I had r squared s to the 6th raised to the 4th power, can't you see that you take the exponent of 4 and you distribute to each factor? Just because we have a 1 there doesn't change it. No. So now let's simplify each of these here. Power to a power. What does that mean? We multiply, right? Okay. So let's multiply. You're saying r to the 2 times 1/4, s to the 6 times 1/4. If needed, we have to do some cross reducing. That r to the 2 times 1/4 becomes what? Say it again. 1/2. Why? I'm just asking because somebody else asked me why. The 2 and the 4. 2 divides into 2, 2 divides into 4 twice. So we have r to the 1/2. And let's look at this. S to the 6 times 1/4. Can we do some cross reducing? What can we divide out? A 2. So 2 divides into 6 3 times, 2 divides into that 4 twice. So we have s to the 3 3 over 2. It's simplified. You've done everything that you can do here. You've done everything that you can do here. Now, could we write it as a radical? I mean, I'm happy you get to this point here. Okay? Now, we can write it as a radical, but we have to have, in order to write it as a radical, we have to have a common index. Okay? We have a common index of 2, but if we divide out a 2 from 1/2 and 3/2, what would the exponents be for R and S if we divide out a 2? Because that would be our index. If I told you to write it as a radical. Yes. The common index is 2. I'm just going to put it here just so you can see it. The common index is 2. What it will leave us with is R, S, cubed. It means the same thing. I just left the 2 there just so that you can see. When we have a common denominator, that is our index. What it's going to leave us with are the exponents to the variable R and to the variable S.
But you don't have to put the 2 in the index, right?
You don't have to. I just did that for visual sake. Okay, please don't put 2 in and let me just say this, the correct way, let me write it, the square root of RS cubed. Okay, this is just for visual so that you can see where the 2 went. Okay, that is it. All right, make this example 5. We'll do 2 more and then we'll call it a day. We have here, well, let me write this out. Use rational exponents to write as a single radical. Use rational exponents to write as a single radical. Here we have the 4th root of y times the cube root of y squared. How are we going to simplify this? Okay? Where our directions is telling us what we need to do. It says first we're going to write the radical as, it doesn't say all that, but I'm telling you, it's going to write the radical as a rational exponent. How would you write y, the 4th root of y, as a rational exponent?
Y1.
Times.
Or 3 over 2.
3 over 2? Okay. The cube root of y, remember that cube root is that index is the denominator of the fraction. So you're saying y to the 2/3. This is something you just did. Going back to your the exponent rules. We have a common base raised to a power. So, and we're multiplying. Therefore, we're going to add the exponents. Yes, ma'am. We're going to find an LCD, but we're going to add the exponents. So you're saying y to the 1/4 plus 2/3. Looking for a common denominator, which is what? 12. So 1/4 into 12 become 3/12. And 2/3 into 12 becomes 8/12. So now that we have a common denominator, add the numerator, keep the denominator the same. So we have y to the 11 over 12. Now be mindful in math, my math lab, when if it says write as a single radical, now that we've simplified it, we want to go back and convert it. Okay? So you can write it as the 12th root of y, all raised to the 11th power. And I'm going to double check this weekend and make sure if it doesn't accept this answer, then you can make that exponent apply it to the y. The 12th root of y to the 11th. Both of those have the same meaning. Okay, so that is the number 6. Looks like the letter B, but it's a 6, okay? Let me write this. The number, because I'm not writing this over, the number 6, that's what it is, okay? I wrote it there, so if you need to go back to it, you know that means it's 6. All right, the 5th root of y squared all over the 6th root of y squared. All right, let's convert each of these to a rational exponent. Our numerator becomes what? Y to the what? 2/5. Yes. Our denominator becomes what? Y to the 2 over 6. You just did something like that. It's a quotient. We have a common base. We're going to subtract the exponents. Now, if you want to reduce this to 6 before we move on, we can do that. If you don't want to, we don't have to. You're going to reduce somewhere down the line. Okay. You want to reduce it? Okay, let's reduce. So we have y to the 2/5 all over y to the 1/3. Because it's a quotient, we have a common denominator. We're going to subtract the exponents. We want a common denominator. I heard 15. So 2/5 into 15 becomes, yes, minus, and 1/3 into 15 becomes, so our answer is y to the 1/15. And then let's write it as a radical. And that is what? Excuse me. The 15th root of y. Sometimes my radicals come out looking nice and sometimes it just looks raggedy. Oh well, I try. It's a radical.